Well, hello guys, here Mr. G with another video about rate of reaction for the grade 12. We're going to continue answering questions from this test, but this time the questions are a little bit more challenging, okay? Don't forget to subscribe for the channel so you can get all the other notifications and all the videos I post on very regular basis. This is going to be question 3. And this question states that a group of learners used the reaction between magnesium and hydrochloric acid to investigate one of the factors that affect the rate of the reaction. The following equation represents the reaction that takes place. The learners add 4,8 grams of magnesium ribbons to excess dilute hydrochloric acid. The hydrochloric acid is in excess, that is important, and is dilute. And measure the mass of magnesium reacted per unit time. The result record for the reactions are represented in the table below, in the graph below. The graph is not at scale, and you can see this graph represents the amount of magnesium that is used up until the end. Does the graph represent reactants used or product form? Okay, already we say that one. It represents reactants used. Explain your answer. Well guys, you can see that the graph started from some point, so you did have at the beginning some number of mole of this substance. Be careful, the graph is number of mole, and you can see that the number of mole decreases with time. That is why it is reactant use. So in this case, you can write that the graph shows the reaction start with some amount. You can see there the 0,2 of reactants, and then this one decreases with time. So that one is question 3.1. 3.2. Use the data on the graph to calculate the change in mass of magnesium during the first 30 seconds of the reaction. So all we have to do is to calculate the change in the magnesium for the first 30 seconds. Be careful guys, for the first 30 seconds. So it's from there to there. Okay, so all you have to do is two options. One of them is to calculate the mass in each case for magnesium, and then convert it to number to change in mass. Other option is to calculate the change in number of mole, and then use that one for the change in mass, and that is what we exactly are going to do. So this one is question 3.2. Let's do it on this side here. So we're going to do change in number of mole is equal to final number of mole minus initial number of mole, and this is 0,16 minus 0,2. You get that the change in number of mole is going to be minus 0,04. But guys, the final answer must be positive because we're working the amount of decrease. That minus means that the masses, the number of mole decreases, but no, the final answer must be positive in this case. So this one is mole, okay? So now we will have to calculate the mass. So number of mole is equal to mass divided by molar mass, and then if you substitute, you have that is 0,004. This one is a 4 here, 0,04 equal to m divided by molar mass of magnesium is 24, and then mass is equal to 0,96 grams. Please, that is the answer, but don't get confused. This is not the amount of magnesium used. This is not the total amount of magnesium. This just was the change in magnesium mass from 0 to 30 seconds, or in 30 seconds. That is question 3.2. is quite simple. Calculate the average rate of the reaction in grams per second during the first 30 seconds. And obvious, now they want to calculate the rate of the reaction. Now that question is 3.3. Rate is equal to change in mass, which is what we calculated here guys. This one here is the change in mass. That is what we calculated there in the 30 seconds, same 30 seconds per unit time. So when you calculate this one, you have that is 0,96 divided by 30 seconds, because they say in grams per second. So when you calculate, you will get that the answer is 0,032 grams per second. That is the answer for question 3.3. Is quite simple. The learners repeat the experiment with excess concentrated hydrochloric acid. Copy the graph above into the answer book on the same set of axes and a dotted line to show the curve that will be obtained when concentrated hydrochloric acid is used. Label the curve M. Not numerical values are required. So guys, all you have to do is to draw on the same set of axes. We're going to do it here with another color, but you will have to draw a new set of axes. And in the new set of axes, represent the graph, and then the next one. So now what is going to happen? You're using concentrated hydrochloric acid. Therefore, the reaction will happen faster. And in that fact, therefore, will end before. The time for the amount of magnesium ribbons to be used up will be faster. So this graph, guys, is a greater gradient down. So it will be in this way here. Everything is going to be down here up until it ends there. So this graph is the graph that represent that have a concentrated hydrochloric acid, guys. The question said label this graph M and no numerical values are needed. So this one is graph M and this one is question 3.4. Guys, this is the graph. The graph will end before. It doesn't no numerical values needed, so you don't know when exactly will end before, but just before. So this is the question 3. It is not that challenging as it looks. It's very easy. But thank you for watching. Subscribe for the channel. I'll see you next time. Mr. G